J-Mamo, Luke here, developer advocate at Celestia Labs, and welcome to Mammoth Mode. This is a new show where we chat with winners of the Mammothon hackathon. We learn about the apps they built, and we learn about their experience hacking. And then at the end, we're going to do a fun trivia game to find out how much they know about Celestia history. Today, we're chatting with Saul from zkMedia. Saul and his team built a zero-knowledge proof image editor that verifies image transformations and provides provenance. Let's check it out.
The first step is to create a new project and sign the image that you apply with your ETH address. After you open a project, you can start applying transformations such as rotating, adding text. And once you have the transform image, you can generate a proof. This proof is basically going to create a provenance between the image, the real image, and the transform image. And the next step is that you have to apply that information to IPFS and verify the proof. Once the proof is verified in the smart contract, you can have the provenance of the image and where it comes from. In a gallery, you can see all this information from IPFS and verify that with the smart contract, but also see the image lineage and all the transformations that have been applied.
That was really cool, Saul. So, one of the things about the hackathon is that one of the things that was different about our hackathon is that we gave you a list of ideas to choose from. I'd like to find out, why did you choose to build this project? Why do you think crypto needs this project? And why did you spend a month of your life on it?
Sure. First thing, thank you for having me, Luke. It's a pleasure to be here. Let's first understand what's provenance. Basically, provenance is the property that allows us to track where something comes from, right? So when we build with zkMedia, it's a product that allows us to track the transformation of images. This is very helpful because a photographer, maybe a newsletter, or anything that has to create online content doesn't have a way to prove how it's been transformed. So as long as you have an image with a verified creation date, for example, you can then later transform the image in whichever way you want, basically adding text, blurring, or censoring, whatever. And that is going to allow you to create a trustless and basically permissionless proof that this image has been transformed and where it comes from. So this is very helpful in order to verify this is real, right? So that's the major use cases for this solution.
Okay, so I get it. So in one, it protects the photographer's intellectual property, that somebody hasn't taken your image and modified it to something else. But I think more so that in this world of where you can AI anything and create any image of anybody doing anything, that it verifies truthfulness. Assuming you at least trust the creator, you can verify that this image actually was it was a photograph that was really taken, not generated by AI. Am I getting that right?
Yeah, you could do that. Exactly. Yeah, that's right.
And who do you think of as your potential users?
Right. For this use case, which is very limited, which is only social media, in this case, images, we could have use cases in social media. We could have newsletters. We could have any newspaper. So all of these online content creators that basically needs to prove where it comes from, it has a very broad use cases here, basically to verify the authenticity and the trustworthy and the authenticity if this newsletter or this medium is actually worth it.
I get it. So you could have, say, it could be integrated into something like Farcaster or some sort of decentralized social media. It could be Farcaster or anything. And New York Times could create a profile, and we could say, okay, we know the New York Times owns this profile. We trust New York Times because they've been doing this for 100 years. So any image that comes from their site, as long as they use the zkMedia, we trust that the image really comes from them, and that any transformations that were made were made by them, right?
That's exactly right, yeah. And then obviously we are not verifying the input, but the first original image, we're verifying all the transformations.
And I guess it could integrate in, and I'm just sort of imagining it's in the future, maybe like a decentralized identity thing. So if the decentralized identity verifies that this identity is trustworthy, and then you verify anything that comes out of that comes from that trustworthy identity.
Yes. At the moment, we are having a research idea on how to generate provenance for anything that is inside a computer. And basically, this is going to allow us stuff like that, where you can track everything down and get the original point of information, which is basically going to be an identity, which is going to be basically stuff like you can actually verify it's real or it's trusted.
Okay, cool. So we already talked about what the app did. Let's get a bit nerdier and do a second demo of the app. And this time I want you to really explain it like you were talking to a CS person, really go into the details technically how it works.
Yes. So the application itself has 4 different elements. It has the UI, which is the one you interact with. It has an API that allows us to like connect with the third element, which is the Speak1 program, which allows us to generate the CK proofs. And then lastly, we have a verification contract that basically verifies the proofs, verifies the provenance, and basically once it's verified, it creates a track between like the original image and the transform image with its hashes. So like the step or like how you would use the application, well, or like how you would develop the application in this case, it's basically like you need to define the library, like the transformation that it's going to be allowed inside the CK VM program, in this case with SP1. And basically we develop a library that allows us to like transform the image, basically rotate it, mirror a section, add a text, and basically create like the most common transformations that you would use for any sort of use case online. So once we have the library, the next step is basically wrap it around the CK, well, in this case, the SP1 program, which is basically defining the inputs that it's going to get and getting the public outputs for the program. The program itself basically verifies generates the hash of the original image, applies the transformations, and then lastly, generates the hash of the of the output image. Once you have that, then you have like the proof, and then with the proof and the public outputs, you can verify that this it's from this. That's how it works on like the very basic. And then as you verify the proof, you have that on the blockchain. Anybody can verify any proof that it's valid. And then lastly, on the UI, we have like the gallery and shows the provenance of everything. Like this image comes from this other one. Then you can edit it, or you can like download again and create more instances of these provenance lineage, basically. The great thing about Succinct and overall CK VMs is that you don't need to know, or you don't need to understand all this moon math called CK and basically understand how cryptography works in a very low level. And basically any Rust program works straight out of the box with SP1. So the way it works, you basically take any Rust program, you put it inside with small changes, with this like super minimal. And once you have that, you're going to be able to generate CK proofs. On top of that, Succinct also has this proof of network that allows us to like basically send a request, and there's proof of network service it's going to send you back the request once it's finished. So the developer experience with Succinct, it's great.
Far out. Tell us all about like what was the experience like in the Mammothon, the support. I mean, it was so the Mammothon, for context, was a 28-day hackathon. You had 28 days. We picked the shortest month of all, February, to build a product, and you did it. Like, what was that like to build a complete app in 30 days, 28 days?
So basically in January, I was doing DevRel, and then all of a sudden after Mammothon, after basically executing all of this idea, I'm like eventually going to become a founder and like hopefully have a successful company.
How does that feel?
So like, it's like another day in the work, to be honest. So like at the same time, if you put it on perspective, it's like, wow, now this is like gonna maybe be huge. Like it's a weird feeling, but like I really like it so far.
What was the experience like in Mammothon? You've been in a lot of hackathons before. Talk about how Mammothon's compared to other hackathons.
Yeah, so like the main difference is that the Mammothon takes a month, which is great. Usually other hackathons is under a weekend or maybe a week, so you don't have so much time to build so many great stuff. So it was very helpful, and also like the team was behind us. Like from the very beginning, once we created a team, we got connected with in this case, in our case, we picked Succinct, and they basically Kay was like the best, and he was like helping us all the way. Like we have some questions. Hey, you have to do that. Hey, you should like think about this idea. Like we basically have this communication flow between like Celestia in one way, Succinct in the other way, and like at the end of the day, we could like succeed thanks to like this support, and it was a very, very important thing. Because not only help us like on the development process or like solving technical questions, but also provided like really good feedback that allow us to be even better than we initially thought.
I think a lot of hackathons are, they're fun things. Like you said, it's a weekend thing. It's a fun thing for developers to get together with friends and just sort of, have our own kind of Olympics. But what was unique about Mammothon is that our goal wasn't just to fund projects, is that we wanted to fund startups. We really looked at teams capable of creating real products that could actually become startups. Okay, so to be clear, hackathon was over. You got $25,000 as a prize, and now you're turning that into a startup, correct?
So we're investing all every single dollar into like working and basically be full time on this idea in order to like make this other topic success.
All right, so how about this? Let's end with this. Mammothon 1 was really successful. We're super happy with you guys and all the other winners. We're now getting ready for two things. We're launching a boot camp, and the boot camp is going to teach both product and engineering skills, and we're getting ready for Mammothon 2 in the fall. What advice do you have for people who are considering whether or not to sign up for Mammothon and like also our boot camp?
Oh, okay. So the structure of Mammothon is great because from the first day, you have great support. And not only you have support throughout the process of basically developing everything, after it's finished, like you're still in contact with the team. They provide you with connections if you need something from that. It can give you much more value than just having the hackathon you finish and then you forget about this idea. So like the main value of this hackathon in particular is that they help you go to the next step, which is usually very challenging. You have legal problems, you have technical questions, you have organization or operation stuff you actually need to cover as well. And with the support from the Celestia team, or like Mammothon overall, like also in code, you can like remove these problems much quicker than otherwise would take you weeks. And this way it's like, hey, I need to talk to like Luke, and like Luke is gonna help me out with, hey, I have this problem, can you help me out? And it's very open, everybody's super nice, and like they have helped us a lot.
All right, dope. Okay, cool. All right, so we are going to end this with a trivia contest. There are 5 questions about Celestia history, and let's see how well, they're multiple choice. So I'll tell you the question,
Okay, thank you.
and then there'll be 4 answers, and let's see how well you do, how well you know Celestia. Okay, the first question is, what was the name of Celestia's first major testnet? Was it Mocha, Arabica, Mamaki, or Espresso?
Arabica.
Nope, the answer is Mamaki. That is one from the archives, though.
We've asked. Okay.
Okay, what is the main purpose of Celestia's light nodes? Is it to validate transactions, to store the entire blockchain history, to sample data availability, or to process smart contracts?
Ledger CS process data sampling.
What is the name of Celestia's consensus mechanism? I'm tempted not even to give you multiple choice. I bet you know it, but the multiple choice is proof of work, proof of stake, tendermint, or proof of history.
Tendermint.
Yes. Okay. 2 for 3. Number 4. Celestia has a namespace system. What is the main purpose of Celestia's namespace system? Is it to organize smart contracts, to enable multiple applications and rollups to share block space, to categorize transactions, or to manage validator sets?
It's the letter P.
B. Yes. Okay. 3 for 4 so far. Last one, see if you can get 4 for 5. In what year did Celestia mainnet launch? Was it 2021, 2022, 2023, or 2024?
2022.
Sure.
I think so.
2023.
2023?
Yeah.
All
Mainnet.
right, okay.
Yeah. All right, cool. Thank you very much. Any party messages you want to share with anybody?
No,
zkMedia is going to need your first 100 users. How can people, zkMedia needs its first 100 users. How can people find out more information?
So we have a Twitter account. Over there, we're posting the updates. So far, the product it's not running, but like we are gonna get to run it very soon. We're gonna keep posting anything in the Twitter account. So follow us on Twitter. And if you have any questions, you can also reach out to me in Twitter or Telegram at SaulGardep. And if you have any question, you can let me know.
Perfecto. Gracias. All right. Thank you, everybody. We'll see you back for the next episode very soon. Bye-bye.